All right, on to 7.1, the Laplace transform. All right, so this is the formula that you have, and you know, the mathematician Laplace, or Laplace, however you say it, he used this to solve differentials. So first we got to get used to transforming functions back and forth. And so you could see one thing about notation, just keep in mind, like here's a lowercase. So you're going to transform something, you'll get a lowercase, and you could see that is the capital letter. So it's showing that transformation there. Not a big deal. We're just going back and forth from S's to T's and that sort of thing. So to just, you know, this is really just going over the definition of Laplace transform. So first example that we have is the easiest one, and it's evaluate the transformation of the function 1. Okay, so using the formula, we'll have 0 to infinity, e to the negative st, and then times 1 dt, right? And just going back to our improper integrals, right? So when you have something like this, now, not necessary to do this every time. I mean, if you get used to it, just know that you are taking the limit as b goes to infinity. So this way, it's a little bit, makes a little more sense on taking the antiderivative. So we would get a negative 1 over s e to the negative st, and then evaluate from 0 to b. So I'm going to get, when I plug in, negative 1 over s e to the negative s times b. Now remember, you're plugging in only for t, right? And then here you'll get a plus 1 over s. If you plug in that 0, you get 1 for e raised to the 0. So this is the part you have to remember. What is our limit of, you know, you have that e raised to the negative sb, so that's going to infinity. If you remember your exponential functions, right, for a negative, right, e to the negative x would look like that. So as it approaches infinity, you know that's going to be 0. So you get 0 plus 1 over s, or just 1 over s. So just to help you guys out, and I'll put these on a I'll list all the little rules that we're going to have as we go along. If I had a 5, right, that would be 5 over s. If I had a 2, or let's say a negative 2, that'll be a negative 2 over s. So any constant is going to be divided by s, and we'll get that going a little bit later. The next basic function that you're going to see is, you know, if you have t, or t squared, or t cubed, or anything along those lines there. So doing the same thing here, right? You got 0 to infinity. And now we have t dt. So this is a by parts, right? Just to show you by parts, right? U dv, here's a little chart, t, 1, 0, and over here you're going to have e to the negative st, so negative 1 over s, e to the negative st, and then a 1 over s squared, e to the negative st. And then just remember your rules, right? Plus, minus, so we wind up getting negative t over s, e to the negative st, and then minus 1 over s squared, e to the negative st, and then you're going to evaluate from 0, well, let's just say infinity. We know what we're doing here, right? So when you type it, when you write it in, my bad. But I mean, remember, this is improper integral. So if you need to use that b, you can. Okay. All right, so if we plug in, like if you want to plug in the b, that's fine. You're plugging in b for t. And b is going to infinity. And then minus, you're plugging in 0, so it'll be 0 minus, and then it's going to be a 1. So you'll be left there. Again, with these, right, goes to 0, because you're going to infinity. So we're going to just be left with 1 over s squared. All right, so I want to show you another couple of these, right? As you go along and you're doing this, let's do t squared, okay? So the only difference here is this is going to be squared up here. So again, we could use the chart just to help save time. T squared, 2t, 2, 0, right? And here you're going to get e to the negative st, negative 1 over s, e to the negative st, 1 over s cubed, s squared, e to the negative st, and then the last one's going to be negative 1 over s cubed, e to the negative st. Again, alternating the signs, right? So you have a plus, minus, plus. Okay, so what it'll look like is negative t squared, e to the negative st over s minus 2t, e to the negative st over s squared, and then minus 1 over s cubed, 2 over s cubed, e to the negative st. And just to do this real quick with you guys, you could start plugging in like with infinity, right? But you can see that if you plug in, that b that's going to infinity, all of those are going to 0. So you would have like 0, right, minus, and then if you plug in 0, this is 0, this is 0, and you're only left with this last term. So you have a negative 2 over s cubed, because if you're plugging in 0 for the exponent, you get 1, and then that's going to give you a 2 over s cubed. Okay? So you could see, like here we have, I just want to kind of show you the pattern. Here we're going to have 1 over s squared. If you have t squared, you get 2 over s cubed. So you could probably see the exponent of s is increasing by 1. How do we get these other numbers, right? So I just want to do one more to show you the next one, right? And you could do the same thing, and I'm just going to focus on that last term because that's really what's giving us the answer here, right? Okay, so as we go along, we're going to have the same thing up until the end. 1 over s squared, e to the negative st, and then same idea, right? You're going like that, boom, 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 right, down. And then if you notice this very last term, and that's what I want to focus on, is just going to be a 6 over, and remember it's plus, minus. So it'll wind up canceling out the minuses anyway, but you have 6 over s to the 4th e to the negative st, and then when we plug in that 0, we wind up getting that just to be 1, so you get this. So if you're looking at these properties here, right, even with the first one we did, 1 over s squared, 2 over 3, and then, 2 over s cubed, and then 6 over s to the 4th. So you could see that the pattern that we have is going to give us a certain property where you could see that the exponent is increasing by 1. So anytime you have a power, t to the n, we know we're going to have s to the n plus 1 because it increases by 1. The top is actually n factorial, okay? And this works for n equals 1, 2, right, and so on. Okay. Okay, the next one I want to do is if you see an exponential function. So let's do Laplace for e to the negative 3t. And here what you could do is combine the exponents. Let's take out that negative, put s plus 3 t dt, right? So if we were doing antiderivative, you know this is improper, but just keep that in mind. You would get e to the negative s plus 3t over negative s plus 3, right? And then when we evaluate, this is going to infinity basically, which is going to give us 0. If you have to put the b in there, that's fine. I'm going to change that to a plus because of the negative here. And then you have this same, but we're plugging in 0. So you can see that's going to be 1 on top, and then you have the s plus 3 there. I kind of messed up my notation here. I just got rid of the negative there because it was minus. So you could see that this winds up being 1 over s plus 3. And if you notice, the 3, we could see that negative 3 is in there. So the rule, right, if you had a 5t, 1 over s minus 5. So the rule that we have here is going to be, say it's e to the a times t, right? We're going to have 1 over s minus a. All right. So basically we went over most of the basic properties. The other two that we have are sine and cosine. Okay, I'm not going to prove it, but you can look at the book if you would like. So for sine, right, you take that coefficient that's inside there, that is your numerator, and then it's s squared plus that number inside squared. Cosine's a little different because it's s over s squared plus 4. So the basic rules here for sine and cosine, so if it's sine kt, right, it's going to be k over s squared plus k squared, and if it's cosine kt, it's going to be just s over s squared plus k squared. All right, and then just remember, if we list all the things we have for our basic properties, any constant, right? So if it's just 1, well, let's put a constant there. Let's put c. So any constant c that you have is going to be c over s. Why do I keep doing that? If you have a power, t raised to the nth power, right? It's just going to be n factorial over s n plus s raised to the n plus 1. If you have the exponential at, so e raised to the at, that's just going to be 1 over s minus a. So these are the ones we want to really remember, okay? And now, with that, you could do any, say we start adding functions together, say it's 1 plus 5t, right? I could rewrite this as the place of 1 and the place of 5t, right? So this is just, or if you wanted to, you could kick out that 5, and because it's constant, put it on the outside. It might be a little bit easier to see, and then just use your properties there. So this is going to be 1 over s, and this is going to be 5 over s squared. And what you guys got to just do is just take your time and use these transformations properly. All right, so if we had this, I would leave the constant 4, right? So it's just 4 over s minus 5, right? Using the exponential one that we had, right, up top. Okay, right there. And then minus 10 times, right, you would have the 2 over s squared plus 4. So you can clean it up, 4 over s minus 5 minus 20 over s squared plus 4. All right, the next one that we have, you could do something with this. It's really the same thing. So I'm going to do 20 over s plus 3 plus 7 over s squared, and then minus 9 over s. And so there you have your transformations that are equipped with different types of functions. Try to get used to using these. You know, once you start solving using Laplace transformations, this has to be pretty quickly done. Okay. The last thing I want to go over is if you had a piecewise function, right? Say f of t was equal to some type of piecewise setup here, which we'll see a little bit as we go along as well. So when you're doing Laplace, okay, of this function, right, we can go 0 to 3 e to the negative st times that function 0, because 0 goes from 0 to 3, and then we're going to add it to 3 to infinity, and you have e to the negative st times 3. dt times 2, what am I doing? Times 2 dt. Now this one you can't, so this is just 0, that's easy, but this one you got to still solve because it's going now from 3, not 0. So it's going to have, you're still going to have that negative 2 over s e to the negative st, but now we're evaluating from 3 to infinity, so it's negative 2 over s e to the negative s, and there's your infinity, which that's going to be 0 plus 2 over s e to the negative 3s. So we wind up getting, since this goes to 0, 2 over s e to the negative 3s, and then that would be your solution for this piecewise. So just be careful with piecewise. You have to kind of break it down, and if it's not in the right form that we like, we can't